Plastics have become an indispensable part of modern life, revolutionizing industries with their versatility, durability, and cost-effectiveness. However, this reliance on plastics poses significant risks, not just environmentally but also for the long-term resilience and adaptability of civilization. The argument for reducing plastic use extends beyond the pressing environmental concerns. It also addresses the inherent vulnerability in depending on a single material that underpins so much of modern life. Just as biodiversity strengthens ecosystems and monocrop agriculture introduces risks of collapse, diversifying our material base and reducing plastic reliance are essential steps toward ensuring a stable and adaptable civilization. The modern economy's overwhelming reliance on plastics can be likened to monoculture in agriculture. Monoculture farming, where only one crop is grown over large areas, has shown to increase vulnerability to diseases, pests, and climate-related disruptions. Similarly, dependence on plastics makes our industries and infrastructure vulnerable to supply disruptions. Plastics are primarily derived from petrochemicals, and any fluctuation in the availability of fossil fuels, be it from geopolitical tensions or environmental regulations, could lead to significant shortages. By reducing our reliance on plastics and encouraging the use of alternative materials, we build resilience into our supply chains and ensure that if one material becomes scarce, others can take its place. The global economy is increasingly interconnected, with supply chains stretching across borders and industries. A disruption in the supply of raw materials for plastics, or in the manufacturing of plastic products, could send shockwaves through industries that depend on them. If this material becomes harder to access due to resource depletion or geopolitical constraints, the resulting scarcity could cripple industries ranging from electronics to packaging. Reducing plastic dependence in non-essential areas mitigates the risk of these kinds of disruptions. It makes room for innovation and flexibility, allowing us to substitute materials as needed and reducing the cascading effects of a supply shock. Just as diverse ecosystems are more resilient to change, diversifying the materials used in manufacturing can spur technological innovation and adaptability. Plastics are valued for their light weight, flexibility, and strength, but alternative materials such as bioplastics, natural fibers, and advanced composites are emerging as viable substitutes. Investing in the research and development of these alternatives not only lessens our dependence on plastics but also opens the door to new technologies and industries that are more sustainable and adaptable to future challenges. By shifting away from a singular dependence on plastic, we lay the groundwork for a more flexible technological future. While plastic's environmental impact is widely recognized, the social costs of this dependence are often overlooked. Many regions that produce or process plastics suffer from pollution and health issues related to plastic waste and chemical byproducts. Communities near production plants or waste disposal sites face heightened risks of water contamination, air pollution, and long-term health consequences. Reducing our reliance on plastics not only benefits the environment but also protects vulnerable populations from the social and health risks associated with plastic production and waste. By focusing on alternatives, we can alleviate these burdens and promote more equitable, sustainable development. A crucial benefit of reducing plastic usage is that it allows for more strategic use of this resource. Plastics have unique properties that are invaluable in certain industries, particularly in medical devices, aerospace, and electronics. By cutting down on non-essential plastic use, we can reserve it for areas where its characteristics are irreplaceable. This approach ensures that in times of scarcity, critical sectors are not impacted as severely, and essential industries can continue to function smoothly. This strategic conservation of resources further strengthens the resilience of our society by allowing us to prioritize essential functions. Reducing plastic dependence encourages the adoption of materials that are easier to recycle and reintegrate into the production cycle. Unlike plastics, which often degrade in quality after recycling, alternatives such as metals, glass, or innovative biocomposites can maintain their structural integrity through multiple uses. Moving toward materials with better recycling potential fosters a circular economy, reducing waste and minimizing the environmental footprint of manufacturing processes. This shift promotes long-term sustainability, ensuring that we aren't depleting natural resources at an unsustainable rate while also addressing the waste management crisis exacerbated by plastic products. On a broader scale, reducing plastic usage aligns with the need to protect global ecosystems. Just as biodiversity helps stabilize natural environments, diversifying the materials we rely on in industry reduces the environmental strain on landfills, oceans, and wildlife habitats. Plastics are slow to degrade and often accumulate in ecosystems, creating hazards for marine life and polluting the soil and water. By lessening our dependence on plastics, we reduce this ecological burden and create more balanced, sustainable interactions with the environment. This approach not only helps prevent further environmental degradation but also protects the natural systems that are essential for human survival. The movement to reduce plastic usage is often framed around its environmental impact, but the stakes are much higher. Our heavy reliance on plastics represents a systemic vulnerability in modern civilization. By reducing plastic dependence, we foster resilience, adaptability, and innovation across industries, supply chains, and social systems. Much like the dangers posed by monoculture in agriculture or the dominance of human-favored species in global ecosystems, reliance on a single material increases the risk of collapse. Diversifying our material base not only mitigates environmental risks but also ensures the long-term stability and adaptability of human civilization.